Good morning, good evening, knowledge seekers and executors. Welcome to my channel. Today I'm going to talk about the extension of the web services. I was talking about in my previous video about the scalability patterns. The first one was horizontal pattern, vertical pattern, and shared patterns. Now I'm going to talk about bulkhead pattern. So you should have been here. Bulkhead pattern was used in the fault tolerance pattern. It's the same thing which will be used in the scalability pattern also. So it's like earlier, like we mentioned, like it's mainly talking about isolating failures where, like, within the specific component or services. So you have bulk, failures happen. What will happen, like it will take out all those things and keep it aside so that your entire system won't be affected. So by isolating failure within specific components or services, the bulkhead pattern prevents a failure in one part of the system from affecting the entire system's performance or scalability or unscalability. So basically, the moment you have like your service has hosting so many microservices inside that, okay, so many APIs. Predominantly, one particular API has failure, and so many requests were coming on that. So that is what bulkhead pattern which will be coming into the picture. What it will do, it will try to stop that API and stop taking the request or responses for that particular API, and remaining all APIs will be executing so that like your service won't be down. So that is what your bulkhead pattern will be doing. Then the next one is load balancing. So by name itself, you can understanding the balancing the requests and responses and instances and services, all those things. Load balancing pattern distribute incoming request across multiple instances of service to optimize resource utilization and handle increased traffic. So basically it will distribute in such a way where to go, where not to go. So all those things it will be done. And predominantly, the moment you do this one, whenever there is a traffic has been increased, traffic means the request has been increased, so that will understand where to go and where not to go. So that can be doable on that. Load balancers monitor the health and availability of instances, ensuring requests are distributed evenly and maximizing performance and scalability. So it's very pretty clear, like, what it will do. It will monitor all the health and instances. So the moment it monitor, and it will understand like where that, where we can pass it, the where can we distribute the request to this particular instance, which request, which instance will be ready to take the request. That can be controlled by your load balancer. Then the last one is auto scaling. So auto scaling automates the scaling process by dynamically adjusting the number of service instances based on the predefined metrics or policies. So we define, see, in PCF, we have seen the load balancer and auto scaling. So the moment you define some metrics in the PCF environment, the the moment you have deployed your services, it will take up that the rules and whatever the metrics which you mentioned, it will follow that, and it will create and pass the in service instances accordingly. It allows the system to scale up or down based on the real-time demand, optimizing resource utilization and ensure efficient handling of various workloads. So in GCP, like we should have been seeing, like there is this CPU throttling and minimum instance as 0 and on request basis, right? So what that do? So if you keep it like minimum instance as 0, you defined GCP itself will be defining minimum instance as 0, and the CPUs will be allocated on request basis. On the request, the moment request comes, your CPU will be taken that minimum instances, it will be increasing. So by default, it will be 0. So whenever the request comes, your auto scaling will be taken that request and and scale up that, fire up that services according to your request. So bump it up all that, whatever the services or instances are there based on the request. So that's why CPU throttling and minimum instances will be helpful in GCP, which with the commands will, those commands are called predefined metrics. So as we talked about horizontal scaling, vertical scaling, shared service, shared pattern, and the auto scaling, load balancer, and the last one is bulkhead. So all these patterns are predominantly used to balancing your traffic and distribute your services request and increase the performances of your services. So Thank you for watching for my video scalability pattern, and I'm going to talk about the next video about deployment pattern. Thank you.